Hello, my name is Muhammad Ismail Arif bin Muhammad Isa. My metric number is 01DEE20F2040 and I'm from class DEE 5B.
My name is Muhammad Afizal Darazali and my metric number is 01DE20F2052 and my class is DEE 5B.
Today we will make a presentation about an chapter, Fundamental of Renewable Energy.
Question 1. List three types of installation commonly in use with their turbine example for each installation, as well as one stable turbine runner according to each installation type. For the answer, first type is turbo turbine, and impulse type, water turbine design in which a jet of water strike the turbine's blades, designed to have a higher specific speed. In this case, the jet aims to strike the pan of the runner on one side and eases on the other. The flow rate is not limited by the discharge fluid interfering with the incoming jet. Turbo turbine can have a smaller diameter runner than a Pelton for an equivalent power. With smaller, faster spinning runner, it is more likely to be possible to connect turbo turbines directly to the generator rather than having to go via a costly speed increasing transmission. For the second type is Francis turbine. Has circular plate fixed to the rotating perpendicular to its surface and passing through to its center. The water enters the casing under pressure and is guided through a set of fixed or adjustable slots called guide vanes around the casing, which direct the flow of water to the turbines blades at the correct angle. The Francis turbine is stable for low to medium head application but require a relatively large quantity of water. Last type is Kaplan turbine. Water turbine which has adjustable blade and is used for low head and height discharge is an inward flow reaction turbine, which means that the working fluid changes pressure as it moves through the turbine and give up its energy. The inlet is a scroll-shaped tube that wraps around the turbine wicket gate. Water is directed tangentially through the wicket gate and spiral onto a propeller-shaped runner, causing it to spin. Okay, for the suitable turbine runner according to its installation type is Francis turbine. Okay, next, this is example for Francis turbine, turbo turbine, and Kaplan turbine. Next, question 2. Discuss two potential of hydroelectric power plant in generating grid-scale electricity supply and two environmental impact of hydroelectric developments by referring to a real power plant example that have been previously reported in Malaysia. For potential of hydroelectric power plant is mini-scale hydroelectric, a scheme that generates power between 5 kW and 100 kW, feeding it directly into the utility grid or as part of a battery charging or AC power standalone system. Number 2, micro-scale hydropower. Usually the classification given to a small homemade run-of-river type scheme that use DC generator designs to produce electrical power between a few hundred watts up to 5 kilowatts as part of a battery charging and standalone system. Next, to environmental impact of hydroelectric development by referring to a real power plant example that have been previously reported in Malaysia. Number 1, the development of a hydroelectric dam in Tembat and Ketuang Forest Reserve, Hulu Terengganu, has changed the natural habitat of elephant into a modified landscape. This study assesses the land use and land cover change in the forest reserve from 2006 to 2016 to detect the change that have occurred over the period and identify the habitat used by elephant therein. And supervised classification was conducted to identify log-over forest, degraded forest, and water bodies. The development of a hydroelectric dam has contributed to the expansion of the log and degraded forest. Forest opening in the study area promoted the growth of palatable plant for elephant to consume.
In Peninsular Malaysia, there is a hydropower station named Ulu Jenai. This is Ulu Jelai Hydraulic Project, which is located on the Bertang River in the Cameron Highland, has an installed capacity of 372. Environmental problem in Cameron Highland, Malaysia, rampant development and land clearing have sensitive highlands area are prone to landslide and soil erosion, which then contribute to the main water pollution issue in the network of river system. Sedimentation and siltation, the outcome established from previous researches have highlighted factors such as soil erosion, landslide, and agriculture activities, urbanization, and unplanned development associated with land use change have significantly influencing the river water quality in the highland areas. Continuous land use change without proper development plan and law enforcement may critically threaten the stability of river network in the highland area. Question 3. By considering the technical aspect below, demonstrate the principle of hydroelectric in electricity generally with respect to first, generator frequency and voltage control principle. Second, generator synchronization using a synchro check relay. Third, generator operation with speed and voltage regulation. Number 4, generator speed and voltage regulation with drop. Number 5, generator pilot operation and load share. First, the frequency containment in hydropower plant is automatically controlled by speed governor within second turbines, such as fluctuation in the net head and again may diminish the performance of the controllers of the speed governor. Second, the numerical synchronous check relay type SPA U140 is a voltage measuring relay designed to be used when the two power systems are to be connected together. Synchronous check relay can be used for both synchronous check function and voltage check function. The synchronous check function is used when two separate network of two electrically interconnected network sections are to be connected together. The voltage check function is used when a disconnected bus line is to be connected to an energized section of a network. The synchronous check function allows circuit breaker closing only if the voltage on both sides of the circuit breaker fulfill the preset condition as to magnitude, phase, and frequency difference. Third, the size of voltage can be varied by three factors. The size of the magnetic field, the more flux line there are, for the connector to cut. The strength of flux that is directly proportional to the induced voltage. The active length of the conductor, active length meaning the part of the conductor actually pass through the field. The active length is directly proportional to the induced voltage. The speed at which the conductor pass through the field. The faster conductor pass through, the greater the voltage induced. The speed is directly proportional to the induced voltage. Number 4, the power output of a generator decreases as the line frequency rises while using the troop speed control mode for AC electrical power generator. It is frequently applied as the governor speed control mode when a primer mover is powering. A synchronous generator that is wired into the electrical grid is operated by modulating the primer mover rate of power production in accordance with the grid frequency. With droop speed control, the prime mover power is adjusted to 100% at minimum operating frequency, 0 when the grid is operating at maximum operating frequency, and intermediate value at other operating frequency. Number 5, paralleling and load shedding are two concepts that are frequently used synonymously but actually mean two different things in order to prevent any generator from being overloaded. Load shedding is a technique for dividing the load or power demand among several generators. Typically, a load sharing control is used for this, which automatically modify each generator output depend on demand. On the other hand, paralleling in the process of linking two or more generators to work together as a single unit by using paralleling switchgear, which enable the generator to be synchronized and run at the same voltage and frequency. This is typically a combination, even though they can be combined. Load sharing and parallelization are not the same. Overloading can be avoided by loading sharing.